Friends, today I'm now going to discuss a very important thing, that is limits of a complex function. Limits of a complex function. How to determine the limits of a complex function? So before discussing this, you all should know about the limit of real function. So what is actually limits of real function? Before discussing complex function, I am discussing what is limit of the real function. Real function limit. So actually, let us take a brief idea about this. Suppose you have a function, you have a real function f of x. Okay, whether it will exist or not, how you will check by limit? Suppose limit x tends to 0 f of x. What does it mean physically? Whether it is exist or not, how we will check? So to physically make it clear near you, I am drawing a line. Suppose you have a straight line here. Okay, here it is a point. Suppose x equals 0. Okay, so left side, here it is left hand side of the x side, x equals 0. Here x equals negative, and here it is right hand side of the x equals 0. Here x is positive. Okay, limit x tends to 0 means ki approaching towards 0, whether it may be from the negative to 0 or it may be from the positive to 0. Limit x tends to 0 f of x. What does it mean actually? It means actually, suppose you have a point on a path. You have a point on a path, that is, that coordinate is x equals 0, one dimensional path. Okay, and you can approach towards that point from path 1. Path 1 means x equals negative, and from path 2 also x equals positive. From both sides you can approach towards limit x tends to 0. So mathematically, how can I write this? Mathematically, I can write this from path 1 means what? Path 1 means from negative side. From limit x tends to 0 plus means path 2 of fx equals limit x tends to 0 minus of fx, f of x. So what does it indicate? It indicates that means it means limit exists. It indicates that if limit exists, if the limiting value is path independent. Limit exists if limiting value will be path independent. Yeah, if let me write clearly, if limiting value is path independent, then limit will be exist. So this is actually the limits of real function. So but today's our discussion is about limits of complex function. So let's discuss about that. What is the limits of complex function? But before discussing whether the limit of the complex function, let us discuss another important thing, that check whether limit exists or not. So let us take an example of that real function of the limit. Suppose you have a function f of x equals x to the power 5 for x less than 0, and x plus 9 for x greater than 0. So suppose, let me write clearly, if you have to prove whether this is path independent or not, and whether this is path dependent. If you can prove that this is path independent, then you can prove that this limit exists. But if you can't prove that this is path independent, then the limit will not be existed. So let's start discussion. Suppose limit x tends to 0, x to the power 5. Okay, 0 to the power 5, that means 0. but here it is, you are coming from the negative side, limit x tends to 0 minus. But if you coming from the positive side, if you coming from the positive side of the limit, suppose you are writing limit x tends to 0 plus x plus 9, then you will get 9. That means the value is not matching. That means what? It is path dependent. That means the limit of this real function doesn't exist. The limit of this real function doesn't exist. So now let's start discussion about limits of complex function. Limits of complex function. So what do you mean by limits of complex function? Suppose we have a complex Argand plane. Let us take a complex Argand plane. Okay. Let's take a complex Argand plane such that here it is x, here it is iy. Suppose take 4 points in 4 quadrants. Here z0 a point in first quadrant, z0 point in second quadrant, z0 point in third quadrant, z0 point in fourth quadrant. So if I say that the limit of approach, then you can see there is infinite number of path or approach. There is infinite number of path or approach towards z0. So let's take an example actually, then you will be more clear. Suppose I'm taking an example. Suppose limit z tends to 0, z bar divided by z. You have to prove this. Now how can you prove that? You can prove that we know that z equals what? Z equals x plus iota y. Z bar equals what? Z bar equals x minus iota y. So how can you prove that whether limit exists or not? So let's start doing this. Now take this z equals x plus iota y and z bar equals x minus iota y. If you take z bar equals x minus iota y, so you can write converting z to x and y, x tends to 0, y tends to 0, x minus iota y divided by x plus iota y. Okay. Now in case of xy plane, in case of real or in case of anything xy plane, what we know? We know that y and x are related by straight line equation y equals mx. Yeah, we know that x equals y equals mx. So if we put y equals mx value here, so x minus iota mx divided by x plus iota mx. Now here it will be limit x tends to 0 only because y is replaced by x. So you can write here limit x tends to 0, x minus iota mx divided by x plus iota mx. If you take common x tends to 0, x 1 minus iota m, let me write properly, x1 minus iota m divided by x1 plus iota m. If x are cancelled out, then we can say that the value will be, so the value of limit x tends to 0, x minus iota y divided by x plus iota y will be turned out into where? Turned out into 1 minus im divided by 1 plus iota m. Now let's check. If m is what? M is the slope. M is slope of the straight line equation. So m can be different. Suppose you are taking, so let us prove that whether it is path dependent or path independent. You have value 1 minus iota m, limiting value is 1 minus iota m divided by 1 plus iota m. So if you take m equals 1, m equals plus 1, what you will get? You will get 1 minus iota y divided by 1 plus iota y. But similarly, if you will take m equals minus 1, what you will get? You will get 1 plus iota y, 1 minus iota y. both different. That means limit here, limit is path dependent. Here limiting value is path dependent. That means let us represent it graphically. If we try to represent it graphically, you can see there is different approach of path for value of m. There is different approach. That means it is path depending. It is path depending limit. So path depending means we can conclude that path depending means we can conclude that limit z tends to 0, z bar z, this limit doesn't exist. This limit doesn't exist. Let's do some more example. That means when you will get here write a trick for here to do the limit of the complex function. So the trick to do limit of the complex function is, if you get m value in the complex function, then the limit will not be exist. The limit doesn't exist. The limit, because the limit will be what? Because the limit will be, function will be path dependent. Function will be path dependent. So limit doesn't exist. So let's take another example. Let's take another example so that it will be cleared totally. Another example is, suppose you are writing limit z tends to 0, real part of z, imaginary part of z, divided by real part of z, plus imaginary part of z. Here no plus sign, here that means multiplication, here imaginary part of z. That means real part of z means what? Limit x tends to 0. If we convert it into the x and y term, real part of 0 will be x, imaginary part of 0 will be y, x plus y. Now if we put y equals mx, here, limit x tends to 0, y tends to 0, mx square x plus mx. So we will get what? We will get x by m plus 1 by m. So if you put now m equals minus 1, if you put m equals minus 1, this will not defined. But if you put m equals plus 1, if you put m equals plus 1 and limit x tends to 0, then it will be 0. That means what? That means it is path dependent. It is path dependent. Path dependent means what? The limit doesn't exist. Limit doesn't exist. So that's it for today. This is the limit of the, here it is how we can write the limit of the complex function. So thank you so much for patiently watching my video. Bye.